Okay, so I'm putting this video together because some people are expressing some difficulty with this mini project that was assigned. So for this one, we're supposed to basically prove that the k squared, and k cubed theory actually is true. So to this, I actually wanted you to make a 3D object and then make two more identical 3D objects that are just scaled bigger or smaller. So for this example, I chose probably one of the more complicated objects. I assume most people won't choose this one. So we call this an icosahedron. And it's also known as the D20, or the 20-sided dice. So this is a 20-sided polygon. So here we go. So for this one, as you can see in my first page, it says a picture from the internet or drawing of your 3D object. So I just found a picture on the internet. This is a 20-sided object. And this, I just also include the net. So for example, if we were to print this out and cut it out, and then get some glue or tape or something, we would form this 3D object. Next one is a photograph of your three similar shapes. So again, this is an example, so I'm not actually going to, I didn't actually create them, so I just found some pictures, but you will actually create them because you'll have some measurements to do later on. And also prepared for myself these rulers, which I'll be using in a second. So let's get down to the heart of the assignment. So the first one says, find the scale factor k. And it says from A to B, A to C, and from B to C. So when we look at this one above, we're going to assume that this first one is A. So we'll call this one A, this one's going to be B, and this one is C. So for us to find the scale factor, we're just basically comparing lengths. So you just have to find any length of one and compare it to the other, then you'll get your scale factor. So the first one's saying to find the scale factor from A to B, then A to C, then B to C. Okay, so A to B first. So we have, so I get my ruler out, and so here it is. I'm just going to grab this and bring it over. So if I already preemptively did these dotted lines for easy measurements. Again, I'm just going to do roughly. You can do more exact when you do yours. But notice how right here, this first one is, according to this ruler, 2 centimeters in length. From tip to tip, that's 2 centimeters. Now if I do the exact same measurement on the next object, we see that it is, let's line it up right there, it's about 5 centimeters in length. And for my very last one, it's 8 centimeters. So I have 2, 5, and 8. So now if I scroll down, I should say. So this first one had a length of 2 centimeters. This next one was 5 centimeters. And the last one was 8 centimeters. So from A to B, my scale factor is just going to do a ratio of those lengths. So K is equal to, which is the size of B, which is 5 centimeters, divided by the size of our smaller one, which is 2 centimeters. So we get a scale factor of 5 divided by 2, that's 2.5. That's our first one. Now if I compare from A to C, I'm going to do the exact same thing, but now I'm going to say, okay, here we're going to put C on top, so that's 8 centimeters in length, divided by 2 centimeters, and we get, that's going to be 4. Our scale factor is 4 for our second one. And for the last one, K is equal to 8 centimeters over 5 centimeters. Yeah, not as nice a number for that one, so 8 divided by 5, and we get 1.6. So C is 1.6 times bigger than B is basically what it's telling us. Okay, so yeah, so we have 2.5, 4, and 1.6. So let's scroll down to the next part. So the next part is telling us to calculate our areas. So again, just to preempt, then I'm just going to write out. So before we had K is equal to, first one was 2.5. Next one was K is equal to 4. And K is equal to 1.6. Okay, so there's two actual ways to find our K squared value. If we know what K is, all we have to do now is square that value. So if I said K is 2.5, if I just square 2.5, I'm going to get 6.25. So what that means is that we made these things out of paper. Okay, so we made these things out of paper. So if A used like 10 centimeters squared with paper, I'm not actually sure what that is yet. I'm just making up a number right now. To go to B, I'm going to need 6.25 times more paper. So it actually I would require 62.5 centimeters squared of paper because I took that 10, multiplied by my K squared factor. So even though the height or the length increased only by a factor of 2.5, the area actually is 6.25 times greater. We can actually calculate those values though. So I already did the math for this one. And this is what it comes out to be. So you don't have to do that. You can just look up a line and you can find the equation. So it says whatever the length A is, if I go 5 multiplied by the square root of 3 and multiplied by A squared, A is the one of the lengths, it will give us the area of our object. So let me just scroll back up here. We need to get our ruler and measure that. So I say, okay, length A is, for this one, is about 1 centimeter. You see right from one corner to next 1 centimeter. Our next one is around 2.5 centimeters. And this one is about 4 centimeters. So 1, 2.5, and 4. Let's go back here. So 1, 2.5, and 4. So the first one, the A value for this first one is 1 centimeter. A value for this one was 2.5 centimeters, and the A value for this one was 4 centimeters. Okay, so let's plug that in. So I get 5 multiplied by the square root of 3 multiplied by 1 squared. So for this first one, we found the area is equal to 8.66 centimeters squared. Let's do that exact same equation for the next one. This time A is 2.5 we saw, so 5 multiplied by the square root of 3 multiplied by 2.5 squared, and we get 54.1 centimeters squared. And one more time, 5 multiplied by the square root of 3, and we're going to multiply by 4 squared, and we get the area is 138 point, I'll just round there, 139 centimeters squared. So you need significantly more paper. Again, to kind of visualize what does it mean by centimeter squared, take a ruler. Let's say that's 1 centimeter by 1 centimeter. To create this first one, we needed the equivalent of 8.6 of these squares. To create the second shape, we needed the equivalent of 54.1 of about 54 of these squares. To make the last one, we needed about almost 140 of those squares. So here's the cool thing. So when I actually find my K squared values, notice how 2.5 squared is 6.25. But if I also just compare my areas, area of shape A is 8.66, area of shape B is 54.1. Okay, if I take 54.1, I actually measure that value and divide that by 8.66 centimeters squared. It might not be perfect because my measurements weren't exact, but 54.1 divided by 8.66, and we get a value of 6.247. Look at that, it's pretty much identical to K squared. From A to C, 139 divided by 8.66, 16.05. Lo and behold, K squared, if I square this value, K squared is equal to 16. Need 16 times what's more area. B and C, take that 139 divided by 54.1. We get 2.57 around. Let's see what happens. 1.6 squared, 2.56. I found my K squared values. I found my area. Okay. Again, the whole point of this mini project is basically to confirm that this rule, this K squared, K cubed things works. In the next video, I'll just finish it up with volume. But for YouTube, I can only have a maximum of 10-minute videos. So watch the next video if you need to see more.